To discuss the examples on non-linear first order PDE, Cauchy problem on it, we should understand what you mean by initial strip. So x is equal to x0t or x0s, y equal to y0s, and z is equal to z0s. It's become an arbitrary initial data curve. It is given to us. Suppose along that curve, we specify the function p of s and q of s such that together with initial curve, that is this curve, the initial curve is x0s, y0s, z0s, satisfies this equation, that is f of x0, y0, z0. It is actually x0 of s, y0 of s, z0 of s, p0 of s, q0 of s is equal to 0. I will call this as equation number whatever the, let's say 1, and the strip condition, that is d z0 by ds is equal to p0, d into dx0 by ds plus q0 into dy0 by ds. I will say this is equation number 2. Then the initial element, that is x0, y0, z0, p0, q0 is said to be define initial strip for the initial curve. Okay. So then such an initial element x0 of s, y0 of s, z0 of s, p0 of s, q0 of s is said to be define an initial strip for the initial curve x of s, y0 of s, z0 of s. Then the integral surface may constructed with the help of this characteristic strip assume from each point on the initial data and curve precisely up and make up together a smooth surface. So this equation number 1 and 2 which we have discussed here, it is a pair of functions p0 and q0 will satisfy this two equations 1 and 2, and there can be several initial strip associated with the same initial data curve is possible. Hence we can be more than one integral surface passing through given integral curve is possible, because there are many equations will satisfy this, both this equation 1 and 2. So that's why there are different kind of other surfaces also possible. So we should note here that a quasi-linear case, we note that the equation number 1 and 2 will reduce to the, what we are checking there is we are checking that p of x0, y0, z0 into p0, q of x0, y0, z0 into q0 is equal to r of x0, y0, z0. And we are checking del z by del t ds is equal to p0 of q0 into del y0 upon del s. And further, which is linear in p0 and q0. So this equation which is linear in P0 and Q0. Further also we are checking that capital P dy0 by ds minus capital Q dx0 by ds is non-zero. Then this P0 and Q0 is uniquely determined. And this situation suggests a method of solving Cauchy problem for nonlinear partial differential equation. So we'll see the steps for this. So step number 1, to solving a Cauchy problem for nonlinear PDE. Given PDE is f of x, y, z q equal to 0 and the initial data curve, it is x is equal to x0 of s, y equal to y0 of s, and z is equal to z0 of s. This is the initial data curve is determined. You have to determine the function p0 and q0 such that the five function that is x0 of s, y0 of s, z0 of s, p0 of s, and q0 of s, these five functions satisfies the equation, that is equation number 1 and 2, which we have just derived here. That is x0 of s, y0 of s, z0 is x, p0 of x, q0 of x is equal to 0, and dz0 by ds is equal to p0 into d of x0 upon ds q0 dy0 upon ds. So it will satisfy these two equations. So there could be several choice of p0 and q0. One may accept the finding the unique solution for each choice. So if you can choose one, then there will be a unique solution is there. But there is a different values of p0 and q0 is possible. In the step 2, once you choose choice made for p0 and q0, that means the initial strip is chosen. We can solve the last five equation of, that is dx by dt is equal to fp, dy by dt is equal to fq, dz by dt is equal to pfp plus qfq, dp by dt is equal to minus fx minus pfz, dq by dt is equal to minus fy minus qfz. We'll solve this equations, this five equations. Subject to the initial condition, subject to the initial condition, that is x is equal to x0 of s, s, y equal to y0 of s, and z is equal to z0 of s. P equal to P0 of s, and Q equal to Q0 of s. This is the initial conditions are there at point t equal to 0. Hence, we can have the characteristic strip issuing from each point of the initial curve. Hence, we have the characteristic curve, or sorry, characteristic strip issuing from each point of the initial data curve. The corresponding characteristic curves generate integral surface. So the corresponding characteristic curve generate integral surface. That means it will generate a solution surface. And we'll solve certain examples based on this. And the uniqueness for the solution is possible, we'll discuss in the next lecture. But before that, we need to solve certain examples. So let us recall what is the step one. The step one is to write down to find out the value of P0 and Q0 using these two equations. Step two, solving this 5 differential equation subject to the initial condition. Okay, let us solve some examples now. Find the solution of the equation, that is z is equal to 1 by 2 p square plus q square plus p minus x q minus y, which passes through x axis. So this is a Cauchy's problem for non-linear PDE. The initial curve, it is given that x axis. So first of all, the first step is to find out the initial strip. We need to obtain the initial strip. The initial curve is x-axis. So the x-axis can be represented as x0 is equal to x of s is equal to s, y0 of s is 0, and z0 of s is 0. So it is s00 point, that is the initial curve we have given. Now the equation number 1 and 2 which we have discussed here, that is this equation 1 and this equation 2, represent. So we need to substitute the value of x0, y0, z0, p0 and q0 in the function app. So here this is my function app. So I'll say here f of x, y, z pq is equal to 1 by 2 p square plus q square plus p minus x q minus y minus z is equal to 0. This is my function. So to determine this characteristic strip, we'll substitute this x0, y0, z0 into this equation. And we need to obtain the value of p0 and q0 using these two equations. So what we'll get if I substitute this value here, so putting x0 is equal to s, y0 is equal to 0, and z0 equal to 0, we get 1 by 2 p0 square plus q0 square. We will get 1 by 2 p0 square plus q0 square plus p0 minus s, because it is p0 p minus x, so it is p0 minus s, q minus 0 minus 0. So into q0 minus 0, so that is equal to 0. And the other equation, that is d, you can just see the second equation. The second equation is dz0 upon ds is equal to p0 dx0 upon s plus q0 dy0 upon s. So that equation will become dx0 upon s, sorry, z0 upon s equal to p0 dx0 upon s plus q y0 upon s. We know x0 is s, y0 is 0, z0 is 0. So that's why this will gives me 0 equal to p0 into dx0 by s. That is the derivative of this with respect to s will gives me 1 plus q0 into 0. So that will implies that p0 is 0. And if I substitute this value into this equation, putting p0 equal to 0 in, 1 by 2 p0 square plus q0 square plus p0 minus s into q0 equal to 0, we get, so we'll substitute here p0, we'll have 1 by 2 into q0 square plus 0 minus s into q0 equal to 0. So that will leads to something get wrong. Wait a minute. So we'll get 1 by 2 q0 minus s q0. 1 by 2 q0 square minus s q0 equal to 0. So if I take common q0 from this, so q0 into 1 by 2 q0 minus s equal to 0. So that will gives me q0 is equal to 0 or q0 is 2s. So there are two initial. Oh, so there are two. So what we'll have is this 1 by 2 q0 square minus s q0 equal to 0. So that will leads to this, and if I take common q0 from this, we'll have q0 equal to 0 or q0 is equal to 2s. So there are two initial strip is possible. Case number 1 is this, that is x0 is v, y0 is 0, z0 is 0, p0 already upon what we got for p0 is 0 and q0 is 0. And case number 2 is x0 is s, y0 0, z0 0, p0 0 Q0 is 2s. Okay, I will call this is some number, let's say star and double star. So we'll have to solve. Now this is over of the step number 1. In step 2, we have to solve that 5 characteristic equation. So the characteristic equations of this PDE are given by dx by dt is equal to fp. We have the function f. Let us, this is my function f. So the derivative of this with respect to p. Let us write down that function f here, so we'll not need to every time don't want to see back. So it is 1 by 2 p square plus q square plus p minus x into q minus y minus z. This is the function f. So fp, the derivative of this with respect to p, that will gives me p, that is a derivative of p square is 2p, 1 by 2, so 2 will get cancelled. Q, no derivative, 0. Here we'll have p, the derivative of p is 1, so it will have plus q minus y. dy by dt, it is fq, so it is q plus p minus x. dz by dt, it is pfp plus qfq, that will be p into this p plus q minus y plus q into q plus p minus x. dp by dt, the derivative of this, that is as per the formula, it is minus fx minus fzp. So the derivative of this with respect to x will gives me minus 1 into, so it is minus q, minus is already there, so we'll have q minus y, and it is fz, it is minus 1, so that minus minus become plus, so it is plus p. So finally it is p plus q minus y, and del q by del z, sorry, del q by del t is equal to fy minus q fz. Fy, that is a derivative of this with respect to y, will gives me p minus x, but it is of minus sign, it is already have minus, so it is minus minus become plus, so it is p minus x minus a derivative of this with respect to z will gives me minus 1, and this minus 1 with this q will become plus, so that is plus q. So finally we'll have this. Now we need to solve this 5 equation. Any suggestion from your side? You just observe what is dx by dt and dp by dt. dx by dt is this, and dp by dt is also this. They are same. So from this, what we can say, therefore, dx by dt is same as dp by dt. Also, you just observe that this is also same. So dy by dt is equal to dq by dt. So from this we can have the solution now. Now in case 1, so we are solving for case 1. So what is the case 1? Let me write down. The case 1 is this. X0 is V, Y0 0, Z0 is this. So let me write here. X0 is V, Y0 0, Z0 0, P0 0, and Q0 is also 0. So we need to solve this one now. So that will gives me X. If I take the integration, it will gives me X is equal to P plus some constant C1. And here we'll get Y is equal to Q plus some constant C2. If I use this initial condition, using initial condition, that means X0 is equal to V and P0 is 0. It gives me C1 is V. And if I put Y0 is 0 and Q0 is also 0, that will gives me C2 is, that means Y0 is 0, Q0 is 0, C2 is 0. So therefore, we'll have X is equal to V plus P and Y equal to Q. What is our objective is to find out Z. We need to eliminate this V from it. P and a Q per null. What we don't want P, Q, V from the equation. So we need to find out the equation which is in terms of X, Y, and Z. That is the integral surface we are looking for. So this is the things we got. Now what we observe is what is the value of X we got from here. Okay, let me observe something here. What is d by dt of p plus q minus y? That means dp by dt plus dq by dt minus dy by dt. dp by dt we have obtained, it is this p plus q minus y. So it is p plus q minus y. dq by dt we have obtained, it is p plus q minus x. So that will be p plus q minus x. And what is dy by dt? dy by dt it is p plus q minus x, but it is of negative sign. So it is minus p minus q plus x. You just observe that this will be cancelled out. So hence what we get, it is d by dt of p plus q minus y is equal to p plus q minus y. And if I take the separable variable method, so that is d by d plus p plus minus y divided by p plus q minus y is equal to dt. if I take the integration, then it is ln of p plus q minus y is equal to ln of, sorry, is equal to t plus some constant C3. Now using this initial condition, what should be the equation we got? This will gives me p plus q minus y is equal to some constant a into e power t. Let us use this initial condition. The initial condition is this: p0 is 0, q0 is 0, and here y0 is also 0. And t is already 0 here. So the value of a, we have 0. Okay, so using the initial condition, y0 is 0, what is p0 is 0, q0 is 0. We got this side is 0 equal to a into e power 0, that will implies a is 0. So therefore this will leads to p plus q minus y is 0. This is the first thing we got. We have started with here and we got this. Now let us observe d by dt of p plus q minus x. Let us see what will be this. So p plus q minus x will be dp by dt plus dq by dt minus dx by dt. dp by dt which we have obtained it here, it is p plus q minus y. dq by dt we have obtained it, it is plus p plus q minus x. dx by dt we have obtained it, it is but it is of minus sign, that is minus p minus q plus y. So you just observe that p, q, y is cancelled out. So the quantity is left is p plus q minus x. So therefore it is d of p plus q minus x upon p plus q minus x is equal to dt. So therefore we have ln of p plus q minus x is equal to t plus some constant c4. So therefore we get p plus q minus x is equal to some constant b into e power t. Using initial condition, that is x0 is equal to s, y0 is 0, z0 is 0, p0 is 0 and q0 is 0. We get 0, 0 minus s. So minus s is equal to b e power 0. So the value of b we get minus s. So finally what we got, it is p plus q minus s is equal to minus s e power t. And the value of p plus q minus y we already obtained it as 0 here. And also we have obtained it this value, x is equal to here we have used v, so that's why we have to use v here. This is not s, it is v. This is v, this will be v, here it is v. So what are the other things we got? We got x is equal to v plus p and y equal to q, that we got from here. and this one. So ultimately we have to solve these equations and we need to obtain the value of. So if I substitute this y equal to q into this equation, so using p plus q minus y equal to 0 and y equal to q, we get p equal to 0. You just see that q is cancelled out, we'll get p equal to 0. If p equal to 0, we get x is equal to v using this. If x is v, p is 0, then we get q equal to y. Okay, so from this first equation, that is p plus q minus x is equal to minus v e raised to p, will implies the value of y. So the p is already 0, so q equal to will get x minus v e power t, but value of x is v, so it is v minus v e power t. So v is x, so you can take common out v from this, that is v 1 minus e power t. Q is this also, q is this also. If I compare them, okay, so now, sorry, here let me write as x or itself, x, not this. And the value of q, we have y. So that's why it is, we got q equal to x minus v e power t. But value of q, we have obtained it as y. So y is equal to x minus v e power t. So we'll have v e power t is equal to x minus y. So e power t is x minus y upon v, but value of v we already have as, we got x. So that's why this is x minus y upon x. So e power t is this, x minus y upon x. The value of s, we have x. Sorry, not value of s, but value of v is s, x. And value of e power t is this. And hence we have now d by dz, dz by dt. dz by dt from that phi equation, differential equation, that is this whole thing. Let me write. So it is p into p plus q minus y plus q into p plus q minus x. We'll substitute all the value of p and what we got. See, p plus q minus y, we already have 0 here. So this p into 0 plus q. P plus q minus x is minus v e power t. So it is minus v e power t. And the value of q, we already have. The value of q we already have. This x minus e power t. So that is q into, q is this, x minus v into e power t into minus v is into e power t. But what is the value of v we got? It is x. So it is x minus x e power t the value of e power t, we have x minus y upon x. Substitute here. That is x minus y upon x into minus of x into x minus y upon x. This x will get cancelled out. So here the quantity is left x minus x plus y. And here this x is cancelled out. So here we'll have it is y minus x. So finally answer is y into y minus x. So dz by dt is y into y minus x. Therefore dz by dt is y into y minus x. But what will be the value of y, or you can convert that is in terms of e power t. X minus y is this. So y minus x. So ultimately we need to integrate this. And to do that, you have to convert into terms of t. So y minus x, from this we can get y minus x, we get it is from this we get, let us write that one here, x minus y upon x is equal to e power t. So y minus x is minus of x e power t. And the value of x we already have is v. So this will be minus v e power t. So this value we have this. And what about y? Y we get from this x minus v e power t. So the value of y, x is v, so it is v minus e power t. So that's why it is the value of y is this and value of x minus y is this. We'll substitute here. So that is minus v e power t into v minus v e power t. V is common out, and e power t if I multiply inside, then it is minus v square e power t minus e power 2t. So finally it is v square e power 2t minus e power t. That is equal to dz by dt. If you integrate this, integrate with respect to t, then it is dz is equal to v square e power t 2t minus e power t into dt. Now integrate. So will gives me z equal to v square e power 2t minus e power t upon 2. So derivative of e power 2t is e power 2t upon 2. Derivative of e power 2 is not derivative, integration. Integration of e power t is e power t plus some constant. Now we will use the initial condition. The initial condition says that x0 is 0, x0 is, what will be the x0 is v, y0 is 0, z0 is 0, p0 is 0, q0 is 0. Use that one. will gives me, this is v square plus e power 0, that is 1 by 2 minus 1 plus c, z is 0. So that will gives me c is equal to 1 by 2 v square minus, but that goes on the other side, so it will be plus. Okay, so that is the value of c we have. So hence the value of z is v square e power 2t by 2 minus e power t plus the value of c is v square 1 by 2 v square. V square you get take common, so it is v square by 2 you can take common. The quantity is left e power 2t e power 2t minus 2 into e power t plus 1. So this is the things we got, and this quantity will leads to z is equal to v square by 2 e power t minus 1 whole square. So on eliminating, now ultimate goal is to obtain the equation in terms of x, y and z. It is in v and t. So on eliminating, v and t we get, we already have the value of v in terms of x, that is x, and the value of y we have, which we have obtained it, that is this, e power t is this. So that we can use here. We have e power t, we obtained it, it is x minus y upon x. We'll use this too. So that is z is equal to x square by 2 into e power t is x minus y upon x minus 1 whole square. Simplify this one. This will x square by 2 x minus y minus x upon x square. So x square will get cancelled out. So final answer is y square by 2. So final answer we got for this one, that is z is equal to y square by 2. Now case number 2. The case number 2 was, which we have obtained it, is this. That is x0 is equal to s, y0 is 0, z0 is 0, p0 is this, q0 is this. x0 is s, y0 0, z0 0, p0 0, q0 is 2s. Now we need to obtain that 6 equation we have, that we already have dx by dt is equal to dp by dt. If you integrate this with respect to t, will gives me x is equal to t plus some constant, whatever the number we have here, let me say d1. The another equation was dy by dt is equal to dq by dt, will gives me y equal to q plus d2. So hence if I use this initial condition now, that is x0 as s, if I substitute here p0 is 0, this will, using initial condition, we get s is equal to p0 is 0 d1. So d1 is s, and here if I use that one, that is y0 is 0, q0 is 2s, d2 is equal to minus 2s. So we got the d1 and d2. Let's substitute here. So finally, therefore, x is equal to p plus s and y is equal to q minus 2s. Now, we already have observed here. You just see that. That is d by dt of p plus q minus y is equal to p plus q minus y. Also, we have observed d plus p minus x by dt is equal to p plus q minus x. So that things we already have. So that's we use here. D by dt of p plus q minus x is equal to p plus q minus x. This we already obtained it in the case number 1. So we'll not repeat that thing here. So if you integrate this, we'll get ln of p plus q minus x is equal to t plus some constant, let's say d3. So we'll have p plus q minus x is equal to capital D e power t. Now we use the initial condition, that is p0 0, q0 is 2s. So here is 2s minus x, x is s. So it is s equal to d e power t, e power 0. That means implies the value of d is s. So we'll have the value of d is s. So therefore we got is p plus q minus x is equal to s into e power t. And d by dt of p plus q minus y is equal to p plus q minus y. We already have this also. So this is gives me ln p plus q minus y is equal to some constant d4 plus t. So it is p plus q minus y is equal to e into e power t. Using the initial condition, p0 is 0, q0 is 2s, y0 is 0, e power 0. So the value of e we have 2s. So finally we'll got p plus q minus y is equal to 2s e power t. Okay, so let me write down what we got here. How many equations we got? P plus q minus x is equal to, we'll have s into e power t. P plus q minus y is equal to 2s e power t. The other two equation is x is equal to p plus s and y is equal to q minus 2s. So these things we got. Our objective is to obtain the value of x in terms of s and t, y is it in terms of s and t, p which is in terms of s and t, and q is also in terms of s and t from this 4 equation. So we'll have p. We can use this two equation. That means from this equation we'll have y minus q is equal to minus 2s. So q minus y is equal to 2s. If I use this one here, that is q minus y is 2s. So we'll have the value of p. We'll get p equal to, this is q minus y. Q minus y I can put as 2s. So it is 2s e power t minus 2s. We'll take 2s common out. So it is 2s e power t minus 1. So we'll get this value. Using this, that is from this one, what we can write? X minus P is equal to S. So P minus X will be minus S. Putting this value into this equation will leads to P minus X, that is minus S. So minus S plus Q equal to S e power T. So the value of Q is S plus e power T. So it will gives me S e power T plus 1. If I substitute this value of P and Q into the first equation, we'll have X that will gives me, if I add this two, that will leads to S e power T minus 1, and this will leads to Y, which is S e power T minus 1. Now we need to solve. Ultimate goal is the Z, that is dz by dt. dz by dt we have it is P into P plus Q minus Y plus Q into P plus Q minus X. The value of P we already have here, that is this 2s e power T minus 1. P plus Q minus Y is 2st, that is 2s e power T. The value of Q we have this s into e power P plus 1 into P plus Q minus X. P plus Q minus is X into e power T. If we simplify this whole quantity, then what we get? Let's see. We'll get this 4s square e power T into e power T minus 1 plus s square e power T into e power T plus 1. So if I multiply this one inside e power T, so you can take s square e power T common out. S square e power T is common. Inside bracket we got 4 e power T minus 4 plus e power T plus 1. So finally we'll have s square e power T 5 e power T minus 3. This is dz by dt. Now we need to integrate this with respect integrate. So that will leads to dz is equal to s square e power 5 e power 2t. So 5 e power 2t minus 3 s square e power t. So that is z. This is dt into dt. If you integrate this one, this is 5 s square e power 2t upon 2 minus 3 s square e power t plus some constant d5 or d6, whatever the number is there for constant. Using the initial condition, that is t equal to 0 as the z is 0, using initial condition, we get 0 equal to 5 s square by 2. This is minus 3 s square plus d5. So the value of d5 we got, it is 3s square minus 5s square by 2. So finally the value of z we got, it is z is equal to, you just substitute this value of d5 here. To substitute that, s raised to 5 is common out, 5 by 2 is common out. So we'll have It is 5s square by 2 e power 2t minus 1 minus 3s square is common out from this one and this one, and the minus is also common, so that's why it is e power t minus 1. Here is also minus 1, so it is e power t minus 1. This will be the value of z. Ultimate goal is to obtain this s and t in terms of xy. So now we have this equation. We got this 2 times e power t minus 1 into s is x. So we'll use this one to find out the value of s and e power t. Now we have x is equal to s into 2 times e power t minus 1. Y is equal to s into e power t minus 1. So x by y will gives me 2 e power t minus 1 upon e power t minus 1. So it is x into e power t minus 1 is equal to y into 2 times e power t minus 1. So what will be the e value of e power t? If I got the value of e power t and s, then we are through. We can substitute that value there and we got the equation. So that will leads to x e power t minus 2y e power t is equal to minus y plus x. So the value of e power t will give me x minus y upon x minus 2y. So this is the value of e power t. Now what will be the value of s? You can substitute any one of this value, this value. So now we have y is equal to s e power t minus 1. We have got the value of e power t, that is s into x minus y upon x minus 2y minus 1. That is s into x minus y minus x plus 2y upon x minus 2y. So this x will get cancelled out. We have y is equal to minus plus sy upon x minus 2y. This y is also get cancelled. So that's why the value of s we got, it is x minus 2y. So the value of s is this and the value of e power t is this. If you substitute all this value here in this z equation, so therefore z equal to 5 by 2 s square, that is the square of this 5 by 2 x minus 2y whole square e power 2t minus 1, that is the square of this minus 1, that is x minus y upon x minus 2y square minus 1 minus 3s square, that is minus 3x minus 2y square into e power z, that is x minus y upon x minus 2y minus 1. We'll simplify this and final answer will leads to z is equal to 1 by 2 y 4x minus 3y. If you simplify this whole expression, that will leads to this answer. So that is the first or one example we have did for Cauchy problem for non-linear first order PDE. The rest examples will do it in the next lecture. If you have any question, you can ask.